our project titled Solid and Hazardous Waste Management Policy Driven Dashboard. We are Nikhil Shirsate, Arjun Tate, Piyush Bhole, and Harsh Joshi. This work is part of our AML machine learning course. Uh, for this project, we have used analytics tools like Tableau, Power BI, Orange Data Mining to analyze waste management data and build a monitoring dashboard. Introduction. Waste management has become one of the major environmental challenges in modern cities. Every day, large amount of solid and hazardous waste are generated from household, industries, and commercial activities. If this waste is not properly managed, it can lead to serious environmental problems such as air pollution, water pollution, and soil degradation. Hazardous waste is particularly dangerous because it contains toxic or harmful substances that can affect human health and ecosystem. Therefore, data analytics and monitoring systems are important to track waste generation, analyze disposal methods, and support sustainable waste management practices. Objective of our activity. The main objective of our project are: first, to analyze solid and hazardous waste dataset collected from municipal sources; second, to study waste segregation practices, which means separating waste into biodegradable, recyclable, and hazardous categories; third, to evaluate waste management policies that guide waste handling and disposal; fourth, to design a policy driven dashboard that visually represents waste data. Finally, the goal is to support sustainable waste management practices by using data visualization analytics. Theory linkage. This project is connected with several important theoretical concepts. First is solid and hazardous waste management, which involves collection, segregation, transportation, treatment, and disposal of waste. Second is environmental pollution, which occurs when waste is improperly dumped into land, water, or air. Third is human health impact, because hazardous waste can cause diseases and environmental damage. Finally, the environmental laws and policies play a key role in regulating waste management and ensuring sustainable practices.
Waste datasets. For this project, we used municipal and urban waste datasets. The dataset contains information such as total waste generated, biodegradable waste, non-biodegradable waste, plastic waste, and hazardous waste. It also includes location details like city, ward, zone. These attributes allows us to analyze waste patterns across different locations and categories. Data preparation. Before performing analysis, the dataset had to be cleaned and prepared. First, the dataset was imported into the analytics tool. Then we checked for missing values and inconsistent entries. After that, we cleaned and standardized the data to ensure accuracy. The pre-processing step is important because clean data leads to reliable analysis and visualization results. Waste segregation and disposable analysis. In this step, we analyze waste segregation and disposal methods. Waste was categorized into wet waste, dry waste, and hazardous waste. We also calculated segregation efficiency, which indicates how effectively the waste is separated at the source. Next, we analyze different waste processing methods such as composting and recycling. Finally, we compared processed waste with landfill waste, which helps understand whether waste is being recycled or simply dumped. Dashboard components. To visualize the data effectively, we designed an interactive dashboard. The dashboard contains several important components: waste type wise generation analysis, segregation efficiency visualization, processing versus landfill comparison, and waste flow representation through charts. It also includes interactive filters for city and waste type so users can explore the data dynamically. Government initiatives and regulations. Waste management in India is guided by several government policies and initiatives. Some important ones include Swachh Bharat Mission, which promotes cleanliness and proper waste disposal; Solid Waste Management Rules 2016, which regulate municipal waste management; Plastic Waste Management Rules, which address plastic pollution; hazardous and other waste rules, which ensure safe handling of hazardous waste. These policies play a crucial role in promoting sustainable waste management practices across the country. Conclusion and recommendations. In conclusion, improper waste management leads to pollution, environmental damage, and health risk. Dashboards help monitor waste generation, segregation, and disposal more effectively. Policy driven analysis also helps government and organization make better decisions for sustainable development. Some key recommendations include improving waste segregation at the source, increasing recycling and composting facilities, reducing reliance on landfills, strengthening implementation of waste management regulation. By following these practices, cities can move toward cleaner and more sustainable waste management systems.
This is our dashboard that we created using Tableau. The dashboard provides a visual summary of waste management data. The first chart shows city-wise waste generated, collected, and recycled. This helps us compare waste management efficiency across different cities. The second chart represents collection methods such as community collected, door-to-door collections, and transfer stations. It shows how waste is collected and processed. The pie chart shows disposal method wise cost per ton, including recycling, composting, landfill. This helps analyze which disposal method is more economical. The last visualization is a tree map showcase where waste types collected, such as plastic, e-waste, metal, organic waste, glass, and construction waste. Overall, this dashboard helps decision makers monitor waste management performance, analyze disposal strategies, and support sustainable environment policies.